Hello, student. Last class we have discussed about the scalar or dot product of vectors and also cross and cross product of vectors. Now, again not elaborately we have discussed about the scalar and dot product last class. Today we will discuss about the scalar and dot product of vectors. Now, suppose this is a vector, this is angle theta, then A dot B, that is your scalar product. Scalar product of vectors. So, A dot B is equal to A magnitude, B magnitude into cos theta. So, that is nothing but is your A B cos theta. So, now from this we have cos theta is equal to A dot B by A magnitude B magnitude. So, again if the two vectors are given, A and B, then can we also find out the angle between them. This is your cos theta is equal to A dot B by A of magnitude and B magnitude. Suppose A vector is A1 I cap plus A2 j cap plus A3 k cap, and B vector is your B1 I cap, B2 j cap, B3 k cap. Then A dot B is equal to A1 B1 plus A2 B2 and A3 B3, because I dot I, only we product these two vectors, I dot I is equal to 1, but I dot j is equal to 0, I dot k is equal to 0. Similarly, j dot I is equal to 0, j dot j is equal to 1 and j dot k is equal to 0, because these three I, j, k forming a orthogonal triad. This is your x axis, y axis and this is your z axis. These three unit vector along x axis, y axis and z axis. That is why I dot I 1, j dot j 1, k dot I 1, that is why A1 B1, A2 B2, A3 B3. So, A dot B is equal to this. So, dot product is commutative. See the slide, that is your, suppose this is your A vector O A B, this is your B vector, this is your theta and this is your suppose n. So, this is a projection B vector, the projection of B vector on A vector, that is your O n. So, A dot B is nothing but is your, that is A dot B, the projection magnitude of A, into projection of B on A, because this is your A B cos theta. So, B cos theta is your, suppose cos theta is equal to O N B right angle triangle, this is your cos theta is equal to O N by O B. So, cos theta is equal to O N by O B is equal to B vector magnitude. So, O n is equal to B cos theta. In place of B cos theta, we write A magnitude into the projection of B on A. So, this is your A dot B, that is your geometrical interpretation of scalar product. Then come to the properties of scalar product. The scalar product is commutative, that is A dot B is equal to B dot A. In particular, A dot A is nothing but your error magnitude into cos 0, that is A small a is equal to a square. So, a dot A is equal to a magnitude into cos 0, because 0 is the angle between these two vectors, that is a and a itself. So, this is your 1. So, a into 1, that is a square. So, a vector of square is equal to a magnitude of square. Similarly, the scalar product is also associative with respect to a scalar. If we multiply a scalar with a dot product, m into a dot b can also be m into a dot b is equal to m a dot b, or is equal to a dot m b. Already we have discussed about earlier class. For any two vector a and b, a plus b the whole square equal to a square plus b square plus 2 into a dot b. Similarly, the scalar product is distributive over vector addition a dot b plus c. Suppose the three vectors are there a, b, c. So, a dot b plus c is equal to a dot b plus a dot c. Similarly, if R is a vector r1 I cap, r2 j cap, r3 k cap, and S is a vector S1 I cap, S2 j cap plus S3 k cap, then R dot S is equal to R1 S1. Already we have earlier, that is A dot B is equal to A1 B1, A2 B2 and A3 B3. Similarly, if the theta be the angle between these two vector, we can also find out the cos theta is equal to A dot B by A rho magnitude into B rho magnitude. Similarly, so I dot I already we have mentioned, I dot I is equal to what? 1, j dot A also 1, k dot A also 1, because I, j, k are 3 unit vector along x axis, y axis and z axis. I dot j is equal to 0. Similarly, vector projection of A on B, vector projection, suppose vector projection of B on A. So, this is your scalar projection of B on A into unit vector, that is A the vector projection B on A, not on A on B. So, this is your scalar projection B on A is equal to A by A rho magnitude, that is nothing but is your the scalar projection B on A, that is B dot A by A rho magnitude into A vector by A rho magnitude. So, this is nothing but is your B dot A into A vector by. So, this is your vector projection, means that is your scalar projection, the scalar projection into the direction where the vector projection you have to determine, that is your on A, that is your unit vector along the A vector. Similarly, two vector A and B are said to be perpendicular, A dot B is equal to 0. If two vectors are perpendicular, because cos 90 is equal to 0, that is why A dot B is equal to 0, then can we say A and B are said to be perpendicular. Similarly, A plus B is equal to A minus B rho magnitude. A plus B, magnitude of A plus B vector is equal to A minus B vector. Only when if A is perpendicular to B, when A vector is perpendicular to B vector, can we say A plus B rho magnitude is equal to A minus B rho magnitude, where A and B are non-zero vectors. Similarly, if A and B are like vector, then A dot B is equal to AB, and unlike vector, then A dot B is equal to minus AB. Then take an example. Suppose a question like this: find the scalar and vector projection of I, scalar and vector projection of a vector I plus j minus 2k on 2I minus j plus 3k. Suppose then scalar projection is scalar projection B on A, that is your B on A. So, B dot A by arrow magnitude that is A dot A, that is I plus j minus 2k dot 2I minus j plus 3k divided by air magnitude, that is 2 rho square minus 1 rho square plus 3 rho square, the root over. So, that is your 2 minus 1 minus 6 by this is your 2 4 1 5 9 root over of 40. So, this is your minus 5 by root over of 40, that is a scalar projection. Suppose you have to find out the vector projection B on A, then can we say B dot A vector projection. Vector projection we can easily find out, that is B dot A by arrow magnitude into A vector by arrow magnitude. So, A vector by arrow magnitude is your nothing but is your 2, that is your minus 5 by root over of 14 into that is 2I minus j plus 3k by root over of 40. So, this is nothing but is your minus 10I plus 5j minus 15k divided by root over of 14. This is your vector projection, because vector projection is a vector, but scalar projection is a scalar quantity. Find the angle between the two vectors, only you have to find out the dot product between these two vectors and divided by the magnitude of these two vectors, because cos theta is equal to A dot B by arrow magnitude into B magnitude. Then come to cross product of two vector. Cross product of two vector, this is your already we have also discussed A cross B is equal to arrow magnitude B magnitude into sin theta into n cap. So, this suppose this is your A vector, this is your A vector, this is your B vector. Suppose A, this is your B, this is your angle theta, and this is your angle, this is your n cap. This vector is perpendicular to this normal. Suppose this is a vector, this is your n cap, because this whiteboard is a two dimensional object. So, this is if this is A vector, this is a B vector, the angle between them is theta, then this pen is your n cap. This pen is acting as the perpendicular to both A and B. So, in this way, suppose we know that cross product of two vector is perpendicular to both A and B. We know that A cross B is perpendicular to both A and B. So, that is why A cross B is a vector which is also perpendicular to A and B. That is why A cross B is parallel to A cross B is parallel to n cap. So, n cap is the unit normal vector for both A and B. So, from this also we can also find out, suppose we take the magnitude of A cross B. So, this becomes A B sin theta, and this is your n cap. So, n cap is a unit vector, no doubt. So, this is the magnitude is equal to 1. So, when we find out the magnitude of A cross B, this is your A B sin theta. So, from this we also find out the sin theta is a angle between these two vectors. This is your A cross B by A rho magnitude and B rho magnitude. Now, we will start the geometrical interpretation of vector product. Okay. So, what is the geometrical interpretation of vector product or cross product? So, now take a two vector, that is suppose A vector and B vector. Now, we draw a parallelogram. This is this is your n cap. So, if this is your A vector A and B, this is your C, then A vector, now we draw a perpendicular from B on this A vector. Suppose this is your N, this is your O. So, OAN, so this is your angle theta. So, sin theta is nothing but is your OA, sorry, BN by BN, sorry, BN by OB. This is your BN by B vector of magnitude, that is BN B sin theta. So, A cross B is your A cross B. Already we have stated that AB sin theta into n cap. This is your AB means the magnitude of A vector and magnitude of B vector. So, B sin theta is nothing but is your BN. So, A into BN into n cap. So, A is nothing but is your the side of a parallelogram. This is your base of the parallelogram. This is the base of the parallelogram and Bn is the height into n cap. So, this is nothing but is your parallelogram into height, base of the parallelogram and height. This is your area of the parallelogram. We have already known that this is the area of the parallelogram. A cross B is nothing but is your area of the parallelogram into n cap. When we take the magnitude, so area of the parallelogram into n of magnitude, so this becomes your 1. So, area of the parallelogram, the formula derived from this figure, that is area of the parallelogram whose adjacent side are given as A and B, then can we find the area as cross product of A cross B from magnitude. So, that is your area of the parallelogram OACB is equal to magnitude of A cross B. Similarly, the vector A cross B is perpendicular to both A and B, already we have stated. So, then come to the properties of vector product. So, vector product is not commutative because A cross B is not equal to B cross A, that is your minus of B cross A. Okay. A cross B. So, right hand thumb rule, you have already know that if the 3, this is your right hand thumb rule. Suppose this is your unit vector I, this is your j, this is your k. If I cross j is equal to k, j cross I, j cross k is equal to I, k cross I is equal to j. If the reverse direction is occurred, j cross I, suppose j cross I is equal to minus k. So, A cross B is not equal to B cross A. This is equal to A cross B is equal to minus B cross A. So, this cross product of two vector is not commutative. Similarly, if A and B are two vectors and M be a scalar, then M A cross B can also be written as M into A cross B, or which is also equal to A cross M into B, where M be a scalar. Similarly, vector product is distributive over vector addition A cross B plus C. Suppose we have A cross B plus C for 3 vector A B C, we can also write A cross B plus A cross C. So, cross product is distributive over vector addition. The vector product of two non-zero vector is a null vector if and only if they are collinear or parallel. A cross B is equal to 0 if A and B are parallel vector. If two vectors are parallel, then their cross product is 0. So, I cross I and J cross J, K cross K is equal to 0 because I is parallel to I same itself. So, the between them the angle is 0. So, sin 0 is equal to 0. If R is equal to R1 I cap, R2 J cap, R3 K cap, S is equal to S1 I cap, similarly S2 J cap, S3 K cap, then R cross S. Suppose A is equal to A1 I cap, A2 j cap, A3 k cap. Suppose B is equal to B1 I cap, B2 j cap, B3 k cap. Then A cross B is nothing but is your the determinant. You have already studied the determinant in the second unit. So, I j k, and first row becomes your the first vector having the component, that is your A1, A2, A3. Similarly, B1, B2, B3. So, from this we have A2, B3 minus B2, A3 I cap plus A1, B3 minus A3, B1 j cap. Similarly, A1, B2 minus A2, B1 k cap. So, this is you can easily find out the determinant of this vector A cross B. We can easily find out by this method, or by multiplying I cross I becomes your 0, I cross j becomes your k, I cross k becomes your minus j. In this way also you can find out the A cross B. Okay. Then come to the the unit vector perpendicular to normal to both the non-zero vector A and B given by A cross B by A cross B ର magnitude. Suppose we have to find out the unit vector along the unit vector or unit normal vector to both A and B. So, A cross B by A cross B ର magnitude. This is your unit normal vector to both A and B vector. This is your formula. You can easily find out A and B are given, A cross B you have to find out, then find out the magnitude of that vector. If you are given that, suppose a magnitude of mu, suppose you are given magnitude of some value, then you can only multiply this mu. So, you have to, the question is your find the magnitude of a normal having mu which is perpendicular to both A and B. Then can you find out the unit normal into mu. So, this becomes your vector of magnitude mu perpendicular to both two vector A and B, mu into A cross B by A cross B ର magnitude. The area of the parallelogram with adjacent side A and B are given as what? The magnitude of A cross B. The area of the parallelogram for any quadrilateral ABCD is given by half of AC into BD, where AC and BD are diagonal. Suppose this is given as, suppose this parallelogram is given as the two diagonals are given. Suppose two diagonals are given, then you can also cross product this and magnitude of this half. So, half of this, suppose this is your A, B, C, D, then area of this parallelogram is equal to SC cross DB, magnitude of this half. This is your, and the area of the triangle with the adjacent side A and B is also given as half of magnitude of A cross B. Similarly, the vector area. So, you are given that only area means you have to find out the magnitude of A cross B. Suppose you are given that the vector area of a triangle whose adjacent side are A and B vector is given by half of A cross B. You have not find out the magnitude of A cross B, only you have to find out the vector area, that is your half of A cross B. Then come to find the unit vector perpendicular to the vector. Suppose these two vectors are given, that you have to find out the A cross B by A cross B ର magnitude. Suppose you are given, similarly you can also find out all these questions. We have already discussed about the scalar product and dot product, also vector and cross product. Now, we will discuss about the scalar triple product of three vectors. If A, B and C are three vectors, then A, B, C, the scalar triple product, of three vectors A A, B, C, that can be written in this form. A, B, C are separated by comma, or we can say also A, B, C within gap. This can be written as A dot B cross C or B dot C cross A. The order should be maintained. In this case, suppose we take B C cross A or C dot A cross B. So, easily you can find out A cross B, and also with the vector we have to the dot product with the C vector. Here is C cross A and dot product with B vector. B cross C, first we have to find out the B cross C and making the dot product with C. So, this is your scalar triple product. If A is equal to A1 I cap, A2 j cap, A3 k cap, B vector is equal to B1 I cap, B2 j cap, B3 k cap, C vector is your C1 I cap, C2 j cap, C3 k cap. Then can we say A, B, C scalar triple product is nothing but is your determinant of the component, only component A1, A2, A3, B1, B2, B3, C1, C2, C3. So, this is your scalar quantity. So, scalar triple product is a scalar quantity. Okay. So, scalar triple product, this can be determined by this determinant. Also, we can go for the geometrical interpretation. So, from the slide you can also verify that A, B, C scalar triple product, that is C into A cross B, that is the area of the parallelogram OADB into N dot C. So, area of the parallelogram OADB into N ro magnitude, C ro magnitude into cos theta, cos phi, where phi is the angle between the C vector and n cap. So, area of the parallelogram OADB, so C cos phi, because n vector is a unit normal vector, that is equal to 1. So, area of the base of the parallelogram OADB into height, that is nothing but is your volume of the parallel pipe. So, volume of the parallel pipe whose edges are A vector, B vector, C vector. This is nothing but is your scalar triple product. So, volume of the parallel pipe from this the figure we have the formula. Then come to properties of the scalar triple product. If A, B, C are cyclically permuted, then the value of the scalar triple product remains same. So, suppose we write A, B, C, cyclically permuted, that is B, C, A. Similarly, this can be written as C, A, B. So, this is cyclically permuted. Then another property is an interchange of any row, any two vector in A, B, C changes the sign only the scalar triple product with the numerical value unchanged. Suppose we are interchanging the two vector, the adjacent vector. If A, B, C, the scalar triple product, that is your A, C, B. Suppose we interchange these two vector, any two vector, adjacent vector, then can the numerical value are same, having the negative sign. Then the value of the scalar triple product is 0 if two of its vectors are same. If two vectors are same vectors, when two vectors are, suppose A, suppose A, B. So, you want to find the scalar triple product, that is equal to 0, because these two vectors are same. So, another is the scalar triple product is positions of dot and cross product are interchanged, provided that the cyclic order of the vectors remains same. Suppose you have to find out A cross B dot C. Suppose you are given A cross B dot C. So, the value also remains unchanged when we interchange this, but the cyclic order should be maintained. That means, A dot B cross C, A dot B cross C for any 3 vector A, B, C and scalar T. Suppose we multiply T with a vector T A B C, that equal to T into scalar triple product of A B C. Similarly, the scalar triple product of 3 vectors is 0 if any two of them are parallel or collinear. That means, if 3 vectors are said to be coplanar, if the 3 vectors lie on a same plane, then the scalar triple product of these 3 vectors must be equal to 0. Then, if A, B, C, D are 4 vectors, then A plus B, that is also important for short questions. This is also important for short question. Suppose you are given A plus B, C, D, scalar triple product, then can we write A, C, D scalar triple product plus B, C, D. Suppose you are given I 2j plus 3I plus 4j. So, what is the value of this? So, only verify I 2j comma 3I. You can write in this way I 2j 3I plus I 2j 4j. So, this becomes your 0, because here is I, 3 can be taking outside. So, scalar is multiplied with the vector, then that scalar is taking outside of this scalar triple product. So, I means these 2 vectors are same. So, the value is 0, here the value is 0. So, only you can find out the value of this question is 0. Again, similarly, the vector product is also distributive over vector addition. A cross B plus C, we also say A cross B plus A cross C. Similarly, 4 points with positive position vectors A, B, C and D are said to be coplanar. Then can we say DAB scalar triple product plus DBC scalar triple product plus DCA scalar triple product is equal to ABC scalar triple product. Similarly, another is your linearly dependent. You have not studied in your plus 2, then can again you will study in the graduation level. If 3 vectors ABC are said to be linearly dependent, if the scalar triple product of ABC is equal to 0. Linearly dependent means that is your the 3 vectors are said to be coplanar. If the 3 vectors are not said to be coplanar, then the 3 vectors are said to be linearly independent. Okay. Then come to the scalar triple product of 3 vector is a scalar quantity. Already we have mentioned this. Then come to question. Suppose find the value so that the 2I minus j plus k. Another is I plus 2j plus 3k minus 3k, and another question, another vector is 3I plus tj plus 5k are coplanar. So, if the 3 vectors are said to be coplanar, then the determinant must be equal to 0. So, you find you write the only component 2 minus 1 1, 1 2 minus 3, 3 t 5 is equal to 0. So, from this we find the value of t. You can easily find out the value of t. Okay. Then come to the find the volume of the parallelepiped whose edges are these 3 vectors 2 minus 3 4 1 2 minus 1 and 3 minus 1 2. Only we have to find out the scalar triple product. Another question already we have discussed, what is the value of I comma j comma 3j plus 3I plus 4j. That value is a scalar triple product of this value is equal to 0. Another is find the unit vector in space which make angles 45 and 60 degree with x axis and y axis. If a unit vector making an angle 45, so this is your cos 45. So, we know that cos square 45 degree plus cos square cos 60 degree whole square plus, suppose that unit vector making an angle suppose gamma, cos gamma the whole square is equal to 1. Already we have know that from the direction cosines, the cos square alpha plus cos square beta plus cos square gamma is equal to 1, or L square plus m square plus n square always equal to 1. So, this is cos 45 is equal to 1 by root 2 the whole square plus cos 60 is equal to 1 by 2 rho square plus cos gamma rho square is equal to 1, or cos gamma rho square is equal to 1, that is 1 by 4 plus 1 by 2, that is 3 by 4, that is 1 by 4. So, cos gamma is equal to, so cos gamma is equal to 1 by 2. So, gamma is equal to 60. So, this vector, this unit vector makes an 60 degree with the z axis. Then come to vector triple product. So, in case of vector triple product, we have A cross B cross C. Suppose 3 vector triple product. So, for this year, this chapter may be exempted by the CHSC. So, A cross B cross C. So, this is your scalar triple product. Then we write B A dot C minus C A dot B. This is your formula. A cross B cross C is equal to B into A dot C minus C into A dot C. So, for any vector R, for vector R, we write I, you have to remember this, I cross R cross I plus J cross R cross J plus K cross R cross K. So, this always equal to 2R, this is equal to 2R vector, that is always, because if you are given that R vector, if this question is given, this is for your multiple choice question or any objective question, that is you have to write only 2 into R vector. If R vector is given, suppose R vector is given as suppose I plus 2j plus 3k, then the answer will be 2 into I cap plus 4j plus 6k cap. Then come to let the pairs A, B, C, D can determine a plane, then the planes are parallel if A cross B cross C cross D, A cross B cross C cross D is equal to 0, vector, because cross product of two vector is a vector quantity. So, here this is a vector quantity, this is also vector quantity. These two vectors are multiplied by the cross product. So, the result is a vector quantity, that becomes 0 vector. The vector triple product of 3 vector is a vector quantity. Again, the 4 vectors A, B, C, D, we have A cross B dot C cross D. If we have A cross B dot C cross D, then can we say A dot C, B dot D minus A dot D into B dot C. So, this is your vector quantity, this is a vector quantity. Dot product means that is a scalar quantity. Here is scalar quantity, this is also scalar quantity, this is also scalar, this is also scalar. The two scalar are subtracted, again give the result as a scalar quantity. So, this formula you have to remember this, because if we cross product first and this cross product the second, then taking the dot product, then can we find the this value Okay. Similarly, we can also find out another various questions. Okay, fine. Now we have to discuss about the vector equation of a line. Okay. First, we have to find the vector equation of a line. So, consider a line where we have to take a variable point whose position vector is, suppose this is a line. Now, suppose this is a point, a position vector is a, this is your suppose we are taking the P point, that is a variable point whose position vector is r. Now, this is your O. Suppose you have to find out the equation of the line, equation of a line passing through a point, passing through A and parallel to a another vector, to an another vector B. So, suppose this is your A vector, this line passing through the vector A. Now, we have to take a variable point whose position vector is r. So, r minus A, this is your vector r minus A. Now, we draw another vector, this is B. This vector, this line is parallel to B vector. So, you have to find the equation of this line. So, equation of this line, this r minus A vector is parallel to B vector. That is why r minus A vector is equal to T into B, where T B scalar, because we know that two vectors are said to be parallel if one of the vector can be expressed as some scalar multiple of other vector. So, r minus A, because P A vector is equal to r minus A. So, r minus A vector is parallel to B vector, that is why r minus A is equal to T B, or r vector is equal to A plus T B, where T B any scalar. So, this is a vector equation of a straight line passing through A vector and parallel to B vector. Okay. So, note is the vector equation of a line passing through origin and parallel to any vector B is given by, suppose this vector is passing through origin. So, A vector in place of A, this is taken as 0. So, r vector is equal to T B. Similarly, a vector equation of a line passing through 2 points. Suppose you are given, suppose a vector equation of a line passing through 2 points. Suppose this is your A, this is your B, B having position vector as B, and so now we take another vector with a variable point, that is position vector as r. So, this is taken as r vector is nothing but is your x I plus y j plus z k, or this is your x comma y comma z. This is a variable point lies on this point moving hither and there, so forming a line. So, this is your locus of the point P. So, this line passing through A B. So, A B means what? A B means the vector is your B minus A. So, B minus A and another vector is r minus A, r minus A. Suppose we write AP vector is parallel to AB vector, no doubt, because 3 points are said to be collinear. So, AP vector is nothing but is your r minus A is parallel to AB vector is B minus A. Then r minus A can be written as T into B minus A, T into B minus A, or r vector is equal to A plus T into B minus A, or r vector is your r vector A plus T minus A. So, 1 minus T into A vector plus T B vector. So, this is your vector equation of a line passing through 2 points. Okay. 1 minus t, where t is a scalar quantity. This vector, this line passing through a vector and b vector. So, you have to taking another point or variable point whose position vector is r. So, this is your vector equation of a line. Then come to vector equation of a plane. Then come to vector equation of a plane. Suppose we consider a plane. Suppose we consider a plane, and this is a normal vector. This is a normal vector or unit vector or any vector. So, this plane passing through a point, suppose A. Now, we consider another point, variable point. This variable point is taken for this moving hither and there, this forming a plane. So, P having position vector is r. So, P A or A P vector is equal to r minus a, because this point is not given, this point is given. This you have to find out the equation of plane passing through a vector A, and the normal is also given, the perpendicular the vector, this is also given. So, r we have to take another variable point, so that the A P vector is equal to r minus a. This is your r minus a vector, A P vector. So, r minus a is perpendicular to n vector. So, we know that if two vectors are said to be perpendicular, then the dot product is equal to 0. So, the equation of this vector is equal to r minus a dot n vector is equal to 0. So, this is your vector equation of this plane. Similarly, suppose the vector equation of a plane passing through a given point A and parallel to two vectors B and C. Suppose another is given as, suppose second case, this is your first case. Suppose this is a plane is given passing through a point, suppose a vector, and parallel to another this B vector, another vector is C vector. So, you have to find this equation of the plane, vector equation of the plane. So, we consider another variable point whose position vector is r. So, A P vector is your r minus a. So, you have to find out this is a variable point. So, A P is equal to r minus a. So, r minus a parallel to B vector and C vector, which vector is perpendicular to B and C. So, already we have expressed our that B and C, the B cross C is a vector which is perpendicular to B and C, already we have discussed. So, B cross C, this vector B cross C is perpendicular to B vector and C vector. So, r minus a, the equation of this vector this plane is nothing but is your r minus a dot B cross C is equal to 0, because B cross C is perpendicular to B and C, and r minus a is parallel to B and C. So, r minus a is perpendicular to B cross C, that is why r minus a dot B cross C is equal to 0, because this is a vector, dot product is a scalar quantity. So, this becomes your 0. So, this is your equation of this plane. You can easily find out this cross product of these two vectors are given, you have to easily find out, and r minus a, r means this is your x, y, z. Suppose a is given as 1, 2, 3, then r minus a is equal to x minus 1, y minus 2, z minus 3, or this can be written as x minus 1 I cap plus y minus 2 j cap plus z minus 3 k cap. In this way you can also find out this. Then come to question, the vector normal to a plane. Suppose a plane is given, then you can easily find out the vector normal to the plane. Suppose a plane is given 5x minus 3y. So, this is your equation of a plane, 8z is equal to 7. So, vector normal to this means you have to only find out the component of x, component of y, component of z. So, vector normal to plane plane is, that is 5i minus 3j plus 8k. So, you have to find out this only component, because r minus a dot n is equal to 0. So, r dot n minus a dot n is given, r dot n is, this is r means what? This is nothing but is your r dot n, that is a dot n. So, r means x, y, z. So, which vector is to be find out, that is why 5x minus 3y plus 8z. That means, we have to write down the 5 minus 3, 8. So, in this way, if this is your dot product, then can we say 5x. So, in this way we can find out all these. So, various questions are there, you can also check the various books, and easily you can grasp the concept of vectors. Okay, thanking you.